All right, and we are back with chapter 5, and this is the last part. We're going to end with El Nino, and then we'll talk about the human interaction. So, El Nino is a worldwide weather event, happens on a very weird schedule. It's random. So, what is El Nino? It's this shift in the Earth's climate patterns that happens, it's temporary. It doesn't happen permanently, but what is every so often you might hear it's going to be El Nino year. And so basically for a year we have these changes to climate around the world. Now here's the thing about El Nino. A couple of things. It occurs randomly. They could be every 3 years, they could be every 15 years. There's no pattern. They're random. On average between 3 to 7 years in between. But again, no pattern. They happen usually over the course of a year, between March and then December. They can be a little bit longer. But they occur with this unique kind of weird switch that happens with oceanic temperature and currents off the coast of Peru. And it's called El Nino because it usually happens, it was first noticed happening over the Christmas holiday. Well, El Nino is the child, the Christ child. So, how does that affect the world? So, for instance, right here, we live in the Great Plains of the United States, you could say us, more tornadoes. In the northeastern United States. So this would be like New York, Philadelphia, Eastern Coast. They have drier weather. If you're in the Southwest, so Los Angeles, San Diego, Arizona, you have a wetter summer, right? In the East Coast, we tend to have fewer hurricanes that year, but in Asia they have more. So it varies around the world. Okay. Now, what is it exactly? This is a map of the Pacific Ocean. Here is South America, here's the equator, here's Australia and Asia. Generally speaking, on average, the water over Asia, Indonesia, in the Pacific Ocean is warmer at the equator than the water over South America. And so what happens is, because the air is warmer here, remember at the ITZ it rises. So you have these huge, huge thunderstorms, all this air. And what happens is this air flows back this way. And when it comes down over here, thousands of miles away in the eastern Pacific, it's cooler and drier. So you have low pressure here, high pressure here, right? Warmer and wetter, cooler and drier. If you look at the ocean, the temperature of the water is warmer to a deeper amount here, whereas it's cooler here. This is the difference between warm and cool water in the ocean. They call it the thermocline. And you have what happens here is you have this different pattern. And this colder water brings with it stuff from the bottom of the ocean. All that stuff that falls to the bottom, it's full of nutrients. It's full of chemicals that fish and plants and animals like. And so here there's a lot of fish that eat it because it kind of wells up because of this colder water. That's the normal pattern. Okay? In an El Nino year, something happens to flip it. And now, again, you have over here, the air is warmer and wetter here and cooler and drier here. The water is warmer here and colder here. And so what happens is you basically reverse this pattern. So it goes this way. And that has effects among the whole world. Obviously strongest in those areas, right? But it alters how much moisture, how much rain you get, more or less. It alters when you get it. Is it spring? Is it fall? Different things. And so some areas during the El Nino year have droughts. Some years have flooding, right? And we talked about right here that it can bring fewer hurricanes, which is beneficial. It can weaken the Asian monsoon, which for a farmer in India means less water for his crops. Sometimes when an El Nino is done and it goes back to normal, it doesn't just go back to normal. So here's a regular year, right? And El Nino happens and does this. Instead of going back to normal, it almost goes back the opposite way and goes normal. They call that La Nina. So in other words, if you go from average temperatures, right, to very, very low temperatures, and then it goes maybe higher than average, back and forth, kind of an oscillation. So La Nina sometimes happens. And because El Nino is often followed by a La Nina, they technically call this whole thing the ENSO, the El Nino Southern Oscillation. An oscillation just means waves. I'll show you what that means. We don't know what causes it. Most we can do is we can see things happening about maybe 4 to 5 months, at the most 6 months before. Say, oh, it's going to be an El Nino year. So here is a map of it. Here's El Nino conditions. So right here, you can see warmer than normal waters, right here. Here is La Nina. Now it's much colder, right? And so here we go. This is the sea surface pattern. La Nina, normal, normal, La Nina, El Nino, back and forth, right? So the El Ninos are almost always accompanied by a La Nina, back and forth. So you have a hotter than average temperature in the ocean, then a colder, back and forth, like a wave. Now, let's talk about how this means. So let's talk about how this plays in. Do we have to worry about climate change, El Nino, and Atlantic hurricanes? So lately, you've probably been hearing the news about how climate change is affecting things. Hurricane Katrina, people wonder was that a climate change that made it worse? Superstorm Sandy, the hurricane that hit Houston, Texas last year, 50 inches of rain in one day. People are saying, well, it's climate change, and let's question that. Is that climate change? So let's talk about some background. Every place on the east coast of the United States, from Maine all the way down to Florida and into the Gulf of Mexico, has the potential of being hit by a hurricane. Okay, and New Orleans and Miami are two very large cities that have a decent amount of risk. Okay. By the way, this is Hurricane Sandy, and Hurricane Sandy. One of the reasons why, as your video will talk about, it made it so worse, and people wondered was this climate change? Was it also occurred as a mid-latitude cyclone was coming in, and they basically hit and combined and amplified themselves. This map shows you the East Coast. Here's Maine, all the way down through Boston, New York, Washington, Carolinas, all the way through. And the colored dot returns that at this point on the coast, right here, what's the average time between when a hurricane hits and the next hurricane? In this area, on average, 22 years. So the darker the red, the more hurricanes come through. So Florida right here, Louisiana, the Carolinas, they get the most. Up here in Maine, New York, some parts of Texas, not so often. They have high risk. Now, we have noticed this. Hurricanes happen in what's called hurricane season. And that's basically August through September, I believe it is. That's when they most happen. Some years, we have a lot of hurricanes. Some years, we have very few. Some years, we have lots of small ones. Some years, we have really big ones. So there's this pattern. So some years are stronger than others. Climate change would suggest, right, that if we are warming the planet and hurricanes need warm water to form, that would mean we have stronger hurricanes, okay, or more of them. But here's the thing. When we look at the data we have, we don't see that trend. We don't see it. We don't see that there are more. We don't see that there are more stronger storms. So scientists can't definitively say that climate change made Hurricane Sandy happen, or that it made Hurricane Katrina worse. Okay? But that's partially because of the data that we have. We don't have enough data yet. Data that we have now says there's no evidence. But here's the thing. We only began using satellites to monitor hurricanes in the 60s. Before that, we had to use airplanes. And before 1944, we didn't have airplanes. So how do we know hurricanes occurred in the ocean? Right? We only knew about the hurricane before 1944. We only knew about the hurricanes that hit land because we saw them. If they didn't hit land, we never saw them. No one knew. We also didn't know how strong they were. We couldn't measure their wind speeds as well. So when you go before 1950, really, or 1960, the data isn't as strong. We don't have as much data. And not only that, what if a hurricane hits in, what about the 1800s? Unless a hurricane blows through a town and someone wrote about it, we don't know. So the data that we have only goes back reliably, really, to about 1950, 1960. Okay? We may know that hurricanes hit, but we don't know for sure how strong they were. So when we talk about hurricanes, the number and the strength, we don't know. But when we put together what we do know, we see this pattern. There's kind of a up and down to it. Now you may say, well, here, you can see here that we're trending a little bit higher and quicker, right? We're having that. But this is only 20 years out of what? How long do we go back? Well, hurricanes have happened since we've had water. So millions of years, right? We don't know yet. We can't say this, that's like saying that, in the last 5 minutes, I haven't seen myself grow. therefore, I'm not growing, right? Well, maybe as an adult, yes, but you know that if you look at somebody over the course of 50 years, you can see how they've grown. Same thing. So climate change, people are quick to throw that term out. There's still a lot of data to be had. I think the one thing the movie does make the interesting point is that we don't know for sure that climate change means Hurricane Sandy's stronger or wetter, but we do know that it has made the sea levels higher, that oceanic sea levels have risen because of ice melting in the Arctic. That we do know. And that if the ocean is deeper to begin with, the sea level has risen, that makes the storm surges even worse. So some ways there have been, but there's still a lot to be learned. So thank you for watching Chapter 5, and now on to Chapter 6.